is counting spaces, all right, that each of these points is away from the y-axis. So W is 2 blocks away. So it's going to be 2 blocks. The mirror image will be 2 blocks in the other direction, W prime. Okay. The y is 2 blocks away. So the y is going to be 2 blocks the other direction, y prime. The x is 7 away from the mirror line. Okay, so that means the x prime is going to be 7 away, okay, from the mirror line in the opposite direction. Connect my dots, and I have my image. Okay, let's record the vertices. All right, so the vertices of my original one there, okay, let's say, what are we calling this? W, X, Y. So in my pre-image, I have 2, 6. Okay, I have 7, 4. And I have 2, 2. However, in my reflected image, it looks like each of the x values are now negatives. So I should have negative 2, 6, negative 7, 4, and negative 2, 2. Let's come back and double check. All right, and that is my W prime, X prime, Y prime. Describe how the reflection affected the x and y values in each vertex. So the x values here were multiplied by negative 1. Okay, the y values stayed the same. And again, the reflection was horizontal, so it makes sense that the y values didn't change. Okay, how could you represent the reflection over the y-axis algebraically? All right, same as we did in the last video. The x values changed, so we're going to have negative 1x, comma, and then just regular y. The y did not change in this particular case. Okay, I want you to go ahead and push pause to see if you can do this one on your own. Reflect triangle DEF over the x-axis. All right, let's see how you did. Okay, so this time our reflection is over the x-axis. Okay, so if you were going to highlight that, it would be this line right here. Is our mirror line. All right, so my pre-image there was 2, negative 2, 7, negative 7, 2, negative 7. For DEF. Okay, if I go through and do this correctly, I would have had 2, 2 for D prime, 7, 7 for E prime, and 2, 7 for F prime. So very similar to the last problem, except now, because it's a vertical reflection, it's the Y numbers that change. So the X didn't change, but the Y numbers be multiplied by negative 1. If I want to represent that algebraically, I would say X, comma, negative 1Y. If I reflected across the X and the Y, all right, so that'd take me from one quadrant all the way to 2 times another quadrant. Okay, then I would have to multiply both by negative 1. All right, let's take a look here. Use the reflection shown to complete each statement below. Give a verbal description of the transformation. In this case, it looks like it's a reflection. Okay, and how do I know what line it is across? Okay, well, I want to imagine that mirror line here. It looks like the y-axis. Okay, so we're going to say reflection, all right, over y-axis. Give an algebraic representation of the transformation. So notice how the y values all stay the same. So like the 2 r's are at the same y number 2. Okay, the 2 q's are at the same y number 8. 2, 8, same thing for the p's. Okay, so my y numbers didn't change, just my x numbers multiplied negative 1x, comma, regular y. List each of the following, if each of the following changed or stayed the same. So the size of the figure, same. The orientation of the figure changed. Okay, and what we mean by that is it's still a triangle, yes, okay, but notice how the r prime is pointing down and to the left, whereas the r is pointing down and to the right. So the orientation of the figure changed. All right, did the orientation of the vertices change? Now we're looking at the order in which they are. All right, if we go clockwise or counterclockwise. Okay, so if I start at, let's say, P, and I want to get to Q, I go clockwise. R, clockwise, back to P, clockwise. But over here, if I start at P, and I want to get to Q, I have to go counterclockwise. Okay, therefore, the orientation of the vertices also changed. Okay. Bella believes the graph shows a translation down, while Scott believes it shows a reflection of the x-axis. Who is correct? And this can be really confusing, especially when you talk about shapes, regular shapes, like a rectangle or a square or a right triangle. Okay, if those shapes, you know, are like this, it's hard to tell sometimes. So the key giveaway is going to be the orientation, okay, of the vertices. So notice here, if I start at M and I go to N, that's clockwise, to O, to L, to M, that's a clockwise, okay? If I start here at M, all right, and I go clockwise, my next point would be L, 2, not the same order. So the orientation has changed. The other way you can tell, okay, when you're looking at this, is by trying to find that mirror line. And notice if it was a translation, if it was a slide, okay, that means O is the bottom left corner, would still be the bottom left corner. And that's not the case. All right, so Scott is correct. It's a reflection. Triangle ABC has the coordinates shown in the table. Miguel is going to reflect the triangle using the rule XY, okay, to negative XY. What is the line of reflection? So if the X's are what's changing, okay, whatever is staying the same is the reflection line, so the Y-axis. Okay, so whatever one stays the same tells you the reflection line. Okay, list the coordinates of the image in the table. So the X's are going to be opposites. The Y's are going to stay the same. So we're going to have 4, negative 6. We're going to have 5, negative 8. And then we're going to finish with 1, negative 3. Last up, okay? Again, just different varieties of how to look at this, sometimes with a picture, sometimes without a picture. Here's without a picture. Point A is 8, negative 1. It's reflected to A prime, which is negative 8, negative 1. So we want to observe what changed. Okay, the X numbers changed, the Y numbers stayed the same. So whichever one stayed the same tells you where the reflection line is, Y-axis. Okay, the algebraic representation would be negative X, comma, regular Y. Okay, because notice 8 times negative 1 is negative 8. So that's why we have to have the negative X. You go ahead and try the second two. Figure reflected from quadrant 1 to quadrant 4. So that's going from, top right to bottom right. So it looks like that's going to be over the X-axis. Okay, which means that my X stays the same and my Y reflects. Okay, now look at the next one here, the point negative 5, 7, reflected to the point negative 5, negative 7. So what didn't change? X didn't change. So the X-axis is the mirror line. Okay, so I go X, negative Y again. All right, hopefully you copy those notes down. I'll see you in class.